So now let's get to a homework problem. So we're going to graph this particular problem again, trying to do it the same way. Solving for y. I could find the x and y intercepts and do it that way as well. Any way that you want to do it, you can do it. So the last example that I did, I used solving for y. We will eventually, I'll go through another problem and do it a different way just to make sure that you understand how to do it. So what I'm going to do is I'm going to move over the 5x by subtracting it. Remember that I subtract or add if I'm moving an entire block. I divide if I'm only, divide or multiply only if I just want to take a piece of that block. So these cancel. This becomes y is greater than, and then I have negative 5x plus 10. Now I like to write the x first because I can see right away, since this is y, I can see this is the slope, and here is the y-intercept. So I've got the y-intercept in that case, and I've got the slope for that one. So when I graph it, it's pretty straightforward. Of course, the b-value is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the y-intercept because that's the b-value. That's what this is right here. And then the slope tells me, so m is equal to negative 5 over 1. So I go down and to the right. So I go down 5. So here's my point, 1, 2, 3, 4, 5, and over 1, which would be right about where that arrow is. So right about there. Okay. Again, do I figure out if it's dashed or solid? And of course, I figure that out by looking at the arrow. Since the arrow does not have an equal sign, it's dashed. So I have a dashed line there. Okay. Just excuse my line there. I know it's not beautiful. And so then we have that dashed line. So that means it's going to be an open plane. I know that for sure, because dashed line always goes with open, closed always goes with solid. And so now we have to figure out, is it going to be to the right or to the left? Now notice again that 0, 0 is not on the line. So that makes it nice because when 0, 0 is not on the line, I can use that to plug it into this equation and test it. So y is 0, x is 0, plus 10, and then I have 0 is greater than 10. Is that true or false? That is false. 0 is definitely not greater than 10. So therefore, the other side where the 0, 0 does not exist, because that's the point I picked, which was this one right here, which is 0, 0. Because it's false, then the other side has to be shaded. So we shade the other side. Here's my half plane. It's an open half plane because this line is dashed, and that's the only difference. Okay, so that's one of the homework problems. Now here we have an equation, just kind of looking at this particular one and determining what the equation is in this particular case. So we have to kind of figure out how do we determine that. So we're going to look at the points. Notice here we have a couple of points here, and I have the x and the y intercepts. So first off, I have 1, 2, 3, 4, 5, 6. So that's negative 6, 0. Remember, x always comes first. And then in this case, I have 0, negative 2. Okay, because that goes down 2. So then I have those 2 points. So what can I figure out from that? Well, I can find my slope. So the slope is equal to y2 minus y1 over x2 minus x1. So I've got that one. And with that, with knowing that, I can plug in the values. I'm going to make this 1.2 and this 1.1. Remember that it does not matter which one you make which. Of course, the y values are always second. X values are always first. So that would be negative 2 minus 0, because the 0 comes here, divided by x2 minus x1. So x2 is 0, so here's x2, and here is x1, minus a negative 6. Okay, so we have negative 2 minus 0, which is just negative 2. Of course, these two become positive, so that's over 6, so that would be negative 1/3. So now I have my slope. I have my y-intercept because that's my b value, which is that one right there. I can write out the equation. Y equals negative 1/3 x. Remember the equation, mx plus b. And then I have minus 2 because b is a negative 2. So there's my equation if I look at that from the standpoint of a line. Now, I'm not 100% sure. I'm thinking maybe I might have missed something here. I'm going to stop the video just for a second, and I'm going to go check that just to make sure that we are okay. So let me just pause it. Okay, so I did figure out that I wrote that wrong, so I want to make sure that I've got that correct this time. So what I should have done was, and when we're looking at this in this particular case, is I'm going to kind of redraw this a little bit. So it should be shaded above here. So notice that the 0, 0 is actually shaded in, and we're trying to figure out what is the equation. So far we have still done this correctly. At least we figured out what the line is. And I've got my line here. So I've got my line here. Now it's not an equal sign. I have to figure out, is that greater than, less than? I already know it's equal to because it's a solid line. So I've got the equal to part. Okay. So I know now that 0, 0 works there. So that means that 0, 0 has to make it true. So what I'm going to do is I'm going to look at this line here. I've got my y equals mx plus b, and I'm going to plug in 0 for x and y. And why am I plugging in 0? Because 0, 0 is part of this line here, and it's easier to plug in zeros than it is to plug in anything else. And now I have to make this condition true. So 0 and negative 2. So what is it? Is 0 greater than, or is 0 less than negative 2? Well, 0 is greater than. So then my inequality, so I'm picking the greater than in this case. So then my actual inequality would be greater, y is greater than or equal to negative 1/3 x minus 2. And that's how I determine whether it is greater than or equal to, or less than or equal to, is I still kind of find a point that's either in the plane or not in the plane, and make that statement either true or false depending on how I set that up. So that's an example. We're going to go through another homework problem in a second.